Hello students, so now we will start with our next chapter, that is Electromagnetic Induction. Chapter is discussion of JEE Mains 2025 January attempt. So first question we have, a rectangular metallic loop is moving out of a uniform magnetic field region to a field free region with a constant speed. Okay, constant speed he said already. When the loop is partially inside the magnetic field, the plot of magnitude of induced EMF with the time is given by. Okay, so what he is saying is basically magnetic field is there. Okay, and then you have like this rectangular loop is there. Okay, this distance, let's say this is x and this is L. L is constant, right? Okay, x is changing, so I can say x is decreasing, right? So dx by dt I can say minus v. Okay, with sign if you want to calculate. Okay, so here when you will write down the flux, what you will say, b into area is what, x into L, right? And then you write down EMF, that is how much, minus d phi by dt. Okay, so if you differentiate, what you will get, BL and dx by dt, right? So dx by dt is what, minus v. Okay, this will come, minus is outside, so BVL. Okay, so I can say EMF is constant, right? Not time dependent. So not time dependent is constant, fourth option. Understood? That's all. Second, if we see regarding self-inductance, he is saying the self-inductance of a coil depends on its geometry. First of all, understand what is the formula. Formula is L is equals to mu naught n square A upon 2 pi r, right? So it depends upon the geometry, so this is correct. Understood? B option he is saying self-inductance, B statement, self-inductance does not depend on the permeability of the medium. It depends. Here you notice there, right? This is wrong. He is saying wrong. C part he is saying self-induced EMF opposes any change in current in the circuit. Yes, if the current is increasing, it will oppose that also. If it is decreasing, it will oppose that also, right? So I can say correct. D he is saying self-inductance is electromagnetic analog of mass in mechanics. See how. First of all, if you understand the mass, let's say compare a cycle and a car. Okay, so if I give a force to cycle, if I want to give a velocity to the cycle, I can give it easily, right? Similarly, if I apply a force, same force to the car, I will not able to give the same amount of velocity, right? Means for the car it is hard to start the motion. Why? Because it is heavier. That's it. Same thing for the stopping also. If I want to stop, let's say cycle and the car moving with the same velocity, okay, cycle will be easy to stop, but car will be hard to stop. Why? Because of mass. So here mass is working like hard to start and hard to stop. Same thing is with the self-inductance also. Okay, right? So this is correct statement. Okay, now come to the E part. Work needs to be done against self-induced EMF in establishing the current. Yes, it is opposing, so work need to be done. So this is also correct. Okay, so I can say B is wrong, right? So B is wrong. So all first two, 1, 2 and 4 option is wrong already. So here only answer came. If you know this much, even B only. So I can say third option is your correct answer. Understood? Next, third. So for third, I can say directly if you apply the formula. See, you can read the question. Okay, if we see the circuit, so we can say EMF minus L di by dt. Okay, and then the resistance is there, right? So minus IR is equals to 0, closed loop, right? Then here put the value. So EMF is given 12. Okay, battery is given 12 volt. Okay, minus L is given how much, 3. Okay, and then after di by dt, so this is given at 8 ampere, rate of change of. Okay, so this will come minus 8, right? Okay, this is only the one mistake you can make. Minus 8 will come. Minus current is asked and resistance is 12 is equals to 0. Understood? From here 8 is a 24, 24 plus 2 36, 36 by 12. So I will come 3. Okay, so that's how. So current is what, 3 ampere. Okay, so this answer, third question answer is 3 ampere. Next, fourth is saying a uniform magnetic field of 0.4 Tesla acts perpendicular to a circular copper disc 20 cm in radius. The disc is having an uniform angular velocity of 10 pi radian per second. Okay, about an axis through its center and perpendicular to the disc. What is the potential difference developed between the axis and the disc? Exact question is in the notes. Exactly same. Okay, and multiple questions are done on the same concept. See how the answer comes. Before that, understand the first basic question which we did in this kind of question. Okay, there was, this is hinge point and this is a rod. Okay, conducting rod rotating with omega. Magnetic field, let's say like this. Okay, B. What you will write down the potential difference between this point and this point. Okay, how you will write down? So you will say first of all EMF dF. Okay, what you will write down? At x distance you assume a dx element. What you will do? Dx element, right? So this element is moving with what velocity? Omega into x, right? Omega x. So what you will write down? V is what? Omega x. Okay, into L is what? Dx, right? This is your dF. Okay, small EMF. Now for the total EMF you integrate, right? So what you will get? EMF is equals to, so the potential difference only, that is, okay, what will this come? B omega x dx integration. X dx from where to where? 0 to L. 0 to L. So what you got? B omega L square by 2. This is how it's come. Okay. Now comes to the question. This is the first basic question. Then we did multiple questions on that you start with here and then there is a thread only. Then from here to here, then you put a here also. Then what is the potential difference between this point, like this? We did multiple questions on that, right? That's okay. Now one of the last basic questions was this only. There was circular loop also. He is asking for the disk in this question. For the disk, if you see here like this, okay, and it is rotating with omega. Okay, so the same thing we will do here also, like assuming the element. Okay, same integration will be there. Distance is omega x, right? Sorry, velocity is omega x at that point, like this only. Same integration. Okay, and same answer will come. EMF is equals to B omega R square. Here L instead of L there is R square. Okay, that's it. Simple. So by this formula, if you put the value, okay, everything is given 0.4, that is 20 centimeter. Put it in the correct unit. Okay, and this is 10 pi. If you solve from here, pi taking value 3.14, you will exactly get third option. Okay, 0.2512. Okay, V. Understood? Got it? So by this formula you will get exact B omega R square by 2. This is in the notes. Okay, exact formula. Now see, next question, fifth question. Okay, so fifth question, if we see what he is saying, a conducting bar moves on two conducting rails as shown in the figure. A constant magnetic field B exists into the page. Okay, the bar starts to move from the vertex at the time t equal to 0 with a constant velocity. If the induced EMF is proportional to t raised to 4, and then what is the value of n? See here, just small thing, geometry you have to solve, nothing else. Okay, this is how this line is going up. Okay, these are the stationary, like this. These are the stationary here. Okay, so draw a perpendicular like here. Now what to do? This is a x. Okay, so I can say dx by dt is what? V. Okay, so x is equals to v into t in the t time, right? This is valid, right? Now what to do? This is x, right? This one is x. This angle is how much? 30. This angle is 30. So how much if I assume this as y, total y, okay, y length. So y by 2 half. Here this is y by 2. Okay, y by 2 divided by x. Perpendicular upon base is equals to 10 30. 10 30 is what? 1 by root 3. So y is equals to what? 2 by root 3 into times x. Understood? Okay. Now write down the flux. Flux is what? I can say area. Area is how much? X in half into base into height, triangle, right? So b into half into base, that is x, okay, into y. So y is how much? 2 by root 3 into x. So flux came how much? B, 2 got cancelled out. So b x square by root 3. Understood? Okay. So from here EMF came how much? So if you differentiate this, what you will get? B by root 3 into 2x dx by dt, that is v, right? And x is what? X I can write down v into t because I want to find out in terms of t, right? So x you can write down v into t. So you put that value here. So what you got? 2 by root 3 v square into t. Okay, everything is constant. V is constant, v square is constant, so it is t raised to power 1. Okay, so he said that only if E is proportional to t raised to power n, so give the value of n. So n equals to 1. N equals to 1. That's your answer. Understood? Just you have to calculate the area. Okay, you see, this is the x, this is the rate of change of this length is your velocity, right? So that's why I assume this as x. Understood? Then I solve the geometry and get the area in terms of x. That's it. Next question. Next question, if you see, this also exactly in the notes. Okay, everything is notes only, nothing. JEE Main will not go out of notes. There is a very less probability, like out of 25 there may be 1 or 2 questions which are out of notes, which carries a high amount of integration or something like that, like we did in the last lecture. Okay, like that it can carry, otherwise everything from the notes. JEE Main is easy. See now, so he is talking about coil of area A and n turns is rotating with an angular velocity omega in a uniform magnetic field B about an axis perpendicular to B. Okay, so he is rotating like this. Like this is the loop, and this is, if you assume this as axis, this is rotating like this. Okay, like this flipping. Okay, so then he is saying magnetic flux phi and induced EMF across it, and at an instant when the B is parallel to the plane of the coil. Okay, so B is like this here from this side. Okay, this side. So when he is in the plane like this, then what is the flux and what is the value of EMF that he is asking. Okay, so first of all, I write down the flux. Okay, so flux, when you will write down, what you will say, B into area into n turns are there, so n into this into cos omega t. This exact formula is written in the notes. Okay, now I know if it is parallel to the B, right? What is the flux? 0. What is the flux? 0. I know, so the flux is what? 0. So for that, omega t have to be pi by 2, right? That I know. I came to know this thing. Get the EMF. EMF, what you will say? Minus will come. Okay, minus d phi by dt, right? So minus will come, but cos differentiation is what? Minus sign, right? So from that also minus will come. So we can say minus plus B A N is as it is. Cos is what? First sine, and then omega t differentiation omega. So omega sine omega t, like this it will come. Differentiation you know better than me. Okay, so sine omega t. Obviously, if you have cleared the 12th, differential integration, everything you know, right? Sine omega t. So put the value of omega t as pi by 2. What you got? EMF is equals to B A N omega. Got it? How I got omega t is equals to pi by 2? Seeing from the diagram, I can see if it is both are B and area is parallel, then what will I say? That flux is what? 0. Nothing, it is not crossing, everything is parallel, right? So I will say here this have to be 0, then omega t have to be pi by 2, right? So here also I will put pi by 2. That's how we got. That's how I explained in the notes also. Okay, exact same thing is in the notes. So this is your answer. So flux is 0 and this is EMF is, so third option, right? So sixth answer is third option. Next, 7th, easy question, right? Okay, consider I1 and I2 are the currents flowing simultaneously in the two nearby coils 1 and 2 respectively. If L1 is self-inductance of the coil 1 and M12 is mutual inductance of coil 1 with respect to coil 2, then the value of induced EMF in the coil 1 is. So it not even confused us, directly gave the values. So I can say this will be how much? Minus L1 into dI1 by dt, and then minus M12 dI2 by dt. Okay, that second current, right? So this is how EMF will come. So where it is L1 I1, but this is not L1 I1 I2. So second option. 7th question answer is your second option, directly from the notes. Okay, this basic formula we